All right, so in that very first example, technically what we are seeing is an example of a negative times a negative. So if you have a negative times a negative, then that's an opposite of an opposite. And we are going to turn that to a positive 7.2. So a negative times a negative is a positive, and 1 times anything is itself. In number 2, you have 1 minus a negative 3. So that's kind of like saying negative 1 times negative 3, or a minus is a positive. So that's like 1 plus 3, or 4. In number 2, you have negative 9 plus negative 4.95. So 2 negatives make a bigger negative, and that's 13.5. So all we're doing is adding the numbers together. In 4, you're multiplying, and a negative times a negative is a positive. So 3.4 times 2 is positive 6.8. And in 5, you're dividing. That's the same as saying negative 15 over 3. So negative 15 thirds simplifies to negative 5. And in 6, these are like fractions because they have a common denominator. That negative can be thought of as on top or bottom. So that negative 5 can become a negative 3. If you have the same denominator, you add the numerators. So negative 2 plus negative 3 is negative 5. And negative 5 over 5 is the same as negative 1. Today we're going to talk a lot.
Please excuse this interruption. The following students please report to the library: Caden Buckingham, Harry Fesco, Enza Notaro, Kerrigan Pritchett, and Lillian Seaman. Those students please report to the library at this time.
All right. Today our goal is to classify numbers. So if you want, you can use the symbol underneath that. Instead of writing out the word natural, you can use the letter N. The natural numbers are the counting numbers. These are the numbers you learned as a child. So you learned 1, 2, 3, 4, 5. And when you got to 10 in preschool, your parents were super excited. And then in kindergarten, the goal is to get to 20, and so on and so forth. Those are called the counting numbers. The number you should notice they're missing is 0. 0 is part of what we call the whole numbers. So the whole numbers are the counting numbers and 0. We use the letter W. The integers are the natural numbers, 0, and the opposites of the natural numbers. The rational numbers are all the numbers that can be written as a fraction, but also include decimals that are repeating or terminating. So terminating means that it has an end. Rational is another word for fraction. So a rational number is a fraction. The word quotient means to divide. So it's all numbers that can be written as division of integers. And remember, integers have no decimals. So think quotient, Q, rational. That's where the Q comes from. The word quotient. And then if a number is not rational, it's irrational. If a number is not rational, it's irrational. And those are numbers that can be written as a quotient of integers. These are your non-repeating decimals, non-terminating, or your irrational numbers like pi, or square roots of non-perfect squares. Okay. So we can classify these numbers by looking at a Venn diagram. So all rationals and irrationals are the subset of the real numbers. So right now in your study of mathematics, all numbers are real. When we get to chapter 5, we're going to learn about non-real numbers or imaginary numbers. But for now, all numbers you know are real. A number that is a real number is either rational or irrational. It's got to fall on one side of the dividing line. So all numbers are either going to be rational or irrational. If a number is rational, then it might also be an integer, it might also be a whole number, and it might also be a natural number. So it can become something more. And then conversely, if a number is a natural number,
Nathan Christie, Riley Cole, Madison Crawford, Ava Dedea, Mackenzie Danhart, Dakota Johnson, Luke Kozarski, and Alexander Weiss. These students, please report to the library at this time.
If it's a natural number, if it falls into the middle, the smallest one, it's everything above it and beyond. So it's also a whole number, it's also an integer, and it's also rational. So if it falls here, then it's going to be everything above it. So let's look at some examples so that we can determine what each is. So, example number 1. We have negative square root 4. To classify a number, you must simplify that number. 4 is a perfect square. So if on your calculator you type in negative square root 4, it simplifies to negative 2. So what that means is that when you classify this, you really have to think of the number as being negative 2. And negative 2 is thus classified as an integer, a rational, and a real. Because remember, it goes up the Venn diagram. So if negative 2 is an integer, it's also a rational, and it's also a real. Correct. It's all 3. In number 2, it's a real and rational because 0.2 is a repeating decimal, and repeating decimals are fractions. So 0.2 repeating as a fraction is actually 2/9, if you wanted to know. So 2/9 or 0.2 is a real rational. Now, if you type in the square root of 8 on your calculator, you get 2.828427125, da 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 da. Goes on and on and on and on and on. So this is a decimal that is not repeating. It doesn't have a pattern. Therefore, the square root of 8 is irrational and real. So the square root of 8 is a real irrational number. Zero. 0 is that special number that has its own classification category. So 0 is a real, it's rational, it's an integer, and it's a whole number. Okay, 4/5. This is a fraction. So a fraction is a real rational. All fractions are real rationals. And then last, we have pi. Pi, if you plug it in on your calculator or if you know anything about pi, pi does not have an ending. So this is irrational. So pi is a real irrational. So again, pi does not have an end. So it is a real irrational. We have properties of the real numbers, and we'll talk about those tomorrow. So what I want you to do for homework tonight is 1 to 25, but you're going to skip 5 to 8 because they're named the properties. So you're doing 1 to 25 on that handout, but you're skipping 5 to 8. So just the front page, but skip the middle 4. So the front page, but skip the middle 4.